Hi, my name is Christopher Sura, and welcome to my final project for Physics E27 Science and Cooking, where I attempt to quantify the taste of a good tasting boiled shrimp. Like many people, I really enjoy a good shrimp cocktail, and that begins with a good boiled shrimp. You know what I'm talking about, the kind where you bite into it and it's crunchy on the outside and juicy on the inside, in a way reminiscent of biting an apple. It's that same sort of effect that you're looking for. Well, I've had a lot of shrimp cooked various ways. It's always boiled, sometimes boiled with salt, sometimes with some lemon added. But it wasn't until I visited friends in the Florida Keys that I learned about white vinegar. Yes, that's right. Simply adding vinegar instead of the salt or the lemon really made a difference in the taste. But they told me there was a secret. Not only did you have to add the vinegar, but you absolutely must plunge the shrimp in an ice bath as soon as they are finished boiling. I knew that it worked, but I had no idea why. I began by sampling the web for recipes. Among about a dozen and a half that were out there, I noticed that there was about a 2-to-1 margin of those who used salt as opposed to lemon juice. Vinegar barely made the charts with just one entry. I also noticed that about 2-to-1 was the ratio for using an ice bath as opposed to just letting the shrimp continue to cook. This made sense based on our Harold McGee reading, where he mentioned specifically that shrimp was actually very good to cook at a boil or in a steamed method because it could stand up well to heat. But it was also one of those fish fleshes that would instantly turn to mush if it was cooked too slowly and delicately. So it had to be done quickly. My experiment was to cook the shrimp systematically at a fixed time and temperature, varying only the ingredient that was mixed with the water, and then whether the shrimp was plunged in an ice bath after cooking. I measured the pH of the water solution, the elasticity of the shrimp and its moisture content, and compared those numbers to my actual tasting results. I'd like to briefly discuss the measurement protocols used for this experiment. The first one is very simple. It's the weight of the shrimp, and in that case, I would simply use a digital Cuisinart scale, accurate to within 1 gram. The next most difficult measurement had to do with the pH of the solution. That would be the boiling water and whether I added any vinegar, lemon, or salt to it. For that, I used pH test strips. These have the paper backing with colored squares on them. They're immersed in the liquid and compared for a readout on the chart in order to determine what the actual pH is. The chart itself is accurate only for whole numbers, so pH from 0 to 14, where colors would end up coming between the two, I would estimate to the nearest half. So if a strip looked like it was between 7 and 8, I would estimate the measurement at 7.5. The most difficult measurement had to do with the elasticity of the shrimp. In order to get a good sample that I could calculate the area for, I decided to actually use an apple slicer. This little device here has a circle in the middle that's exactly 20 millimeters. So I could core a section of the shrimp, get a 20 millimeter circle as the surface area, and then measure the depth of it using a set of digital calipers. This turned out to be a very precise measurement. It's accurate to actually within 1/100th of a millimeter. The jaws have a flat, stable bottom with which to measure the outside of the shrimp is because it could necessarily not be at a right angle. You could compress it ever so slightly in order to get it squared off to get a starting measurement. When it came time to compress it, I used a digital weight set from Scientific Instruments. The kilogram weight was placed on top of the shrimp piece. And then in the digital calipers, the inside caliper piece would actually measure the distance from the weight to the cutting board so that I could get a cross section to see how much the shrimp was compressed. With these simple tools, I was able to get all the measurements I needed for this project. I gathered all the data points into this spreadsheet. of course, with the appropriate formulas and constants set up in order to calculate the elasticity using pascals and the juiciness as a percent of water. And to jump to the final result and leave you not in suspense, let's just say that as far as the ingredients were concerned, with elasticity, vinegar was the winner. The highest level of elasticity meant the highest crunch when you bit into the shrimp, beating out my previous favorite of the salt. And of course, you can see why lemon just didn't seem to taste so good to me. The other interesting point had to do with the juiciness. When I compared those that were in the ice bath versus those that weren't, it was clear that vinegar had a very high effect. Where there was no ice bath, it was only 39.5% juiciness, whereas with the ice bath, it was 47. The effect was far less pronounced using the other ingredients. So the mystery is solved. Vinegar is the clear winner, but only when you use the proper ice bath. Thank you for listening, and I hope you've enjoyed learning about this project.